Now 2021 A-level ni. So 2021 A-level MCQ. Right. It says that diameter and mean density of Jupiter 11 times 104 times respectively to that of Earth. So let's say this Earth. So when you consider Earth, let's say diameter of the Earth, I say capital D. Diameter of the Earth is capital D. Diameter is capital D. Not radius, diameter is capital D. I say density is rho. Density is rho. It's for Earth. Then what can you say about the diameter and density of the Jupiter? Then diameter and density of the Jupiter. Diameter is 11 times larger than the diameter of the Earth. Therefore, it's 11D. It's 11 capital D. Density will be rho O4. Rho O4. And we know gravitational field intensity. If not, I mentioned gravitational acceleration on the surface of the Earth. G is how much? 10. We want to find the gravitational intensity, if not gravitational acceleration on the surface of the Jupiter. I say it's Gj. We want to find Gj. That's our goal. Finding Gj is our goal. Finding Gj is our goal. Right. So if you can do by yourself also. Gj is our goal. Gj is our goal. So then we know that now. So what is the equation we want to use? We know that intensity means G capital mu R squared. Then I can say what? I can say intensity equals gravitational acceleration, right? In G equals G capital M equals what? G capital M equals simple G capital R squared. I know all of you know how this equation came. I don't explain how this equation came. I don't explain. So then we can say that mass means what? Mass means we can say volume into density. Now volume of a sphere means what? 4/3 5 R cube. 4/3 5 R cube. Density is rho. Gravitational acceleration G R squared. Then R squared R cube. There is only one R remaining. So then we can understand gravitational acceleration. Look at it. G is a constant. 4, 3, 5 is a constant. Then you can understand gravitational acceleration is only proportional to what? Gravitational acceleration only proportional to radius of the planet into density of the planet. R. So then you can easily apply this proportionality for the Earth, and you can apply this proportionality for the Jupiter. Then problem solved. Then when you apply this for Earth, it's about G is about 10. G is about 10. Right? Then what can you say about radius of the Earth? It's capital D over 2. Capital D over 2. Density of the Earth is, we know that it's rho. So proportionality 1. So when you apply this for Jupiter, then I can say that Gj proportional to what? Radius of the Jupiter is 11D over 2. 11D over 2. Density of Jupiter is rho over 4. Rho over 4. So if you divide 2 by 1, you get the answer. If you divide 2 by 1, you will get what? Gj over 10 equals what? D rho over 2 cancel out. D rho over 2 cancel out. D rho over 2 cancel out. You will obtain only what? 11 over 4, right? 11 over 4. And then you will obtain what? Gj equals what? If I subject Gj 110 over 4, that means how much? 110 means how much? 55 over 2. 55 over 2 means how much? 55 over 2 means how much? 27.5, right? 27 point something. Then answer is first one. Answer is 27.5. What is the unit of gravitational acceleration if not intensity? M is -2. If not, we can use newtons per kilogram. So how many of you understand this past paper question? Raise your hand. So if you properly do it now, you don't want to draw now. When you are doing this MCQ, you don't need to draw these two what circles. So what you want to draw, what you want to write is you can define density of Earth and diameter of the Earth as density of the Earth is rho, diameter of the Earth is capital D. Based on that 11D rho over 4. So quickly use this equation and get this proportionality. Then you can easily get the answer. So therefore, it won't take so much time. Raise your hands. How many of you understand 2021 level question? Raise your hands. Raise your hands. MCQ. 2000 now. 22 A levels. Sorry, my bad. 2020, I think. 2020 A levels. Now, what it says that a small instrument of mass 10 kilogram is placed. A small instrument of mass 10 kilogram is placed on a planet. The mass of the planet is 3 times and the radius is 2 times that of the Earth. What would be the weight of the instrument on the surface of the planet? Very easy. Neglect all the other effects except gravitation. Now there's a planet, right? Look at it. There's a planet. I say planet is capital P. Mass is planet is capital P. Let's say Earth is simply planet is capital P. Earth is simply. Now they mentioned that mass of the planet is 3 times and radius is 2 times that of the Earth. If I say mass of the Earth is capital M, mass of the planet is 3 capital M, mass of the radius of the Earth is, I say, capital R. Radius of the planet is how much? 2 capital R. This understanding, right? Then they mentioned a small instrument of mass 10 kilogram is placed on the planet, right? Now we placed a small object on the surface of the planet. Mass of that object placed on the planet is 10 kilograms. We'll come to that part later, right? Okay. Now we know what is the gravitational acceleration on Earth. It is about how much? 9.8 ms minus 2. If not, it's about 10 ms minus 2. So gravitational acceleration on the Earth is how much? It's 10. But I don't know what is the gravitational acceleration on the surface of the planet. Therefore, I say it's g. Then you can understand, right? What you want to do? You can say what? G capital M equals G R squared equation. Very easy. G capital M equals G R squared equation. Same idea. And what do you do? Now they have given mass, right? That's it. Now I subject G. If I subject G, because I want to find G. If I found the gravitational acceleration on the surface of the planet, I can easily find the weight of the object on that planet. Because mg, I know mass of the object placed on the planet 10 kilograms. If I want to find the weight of this object, I need to find the gravitational acceleration acting on this planet, g. On the Earth, gravitational acceleration is 10. But I don't know what is the gravitational acceleration on the planet. Target is finding this g. If I found this g, 10 into g, problem solved. That's the answer. Then mass r. Easy. Subject simple g. G is subject simple g. Capital G is a constant. Simple g is what? It's proportional to capital M over r squared. Then I can say what? I can say what? If I apply this equation for the Earth, 10 is proportional to what? Mass of the Earth is capital M, r squared. Radius of the Earth is capital R, proportional to 1. If I apply this equation for the planet, gravitational acceleration of the planet, g, mass of the planet is 3 capital M, radius of the planet is how much? 2 capital R, 2r squared. 2r squared means how much? It's 4r squared, proportionally to 2. So if you want to find the gravitational acceleration on the surface of the planet, divide proportionally 2 by 1. And then I will obtain what? I will obtain easily. I will obtain what? G over 10 equals what? G over 10 equals, look at it. MR squared cancel out if you divide 2 by 1. MR squared cancel out. Then G over 10 equals what? 3 over 4. 3 over 4, right? 3 over 4. That means G equals how much? 3 into 30. 30 over 4. 30 over 4. Now, if you want to find the weight of this object 10 kilogram on this planet, what is the equation? Weight means what? Mg. Mass of the object on this planet is 10 kilograms. Gravitational acceleration on the surface of the planet, thus now I found 30 over 4. 30 over 4. Then I'm getting what? 300 over 4. 300 over 4 means 150 over 2, 75 newtons. 75. 75. Right? But how many of you understand what I told you right now? Raise your hands. How many of you understood what I told you right now? Raise your hands. Right, okay. 10 kilogram mass of the planet. It must be 30 over 4 means 15 over 2. Look at it now. The problem is what? Now they are asking the weight. They are asking what would be the weight of the instrument on the surface of the planet. If they are asking the weight, weight means what? Mg. The mass of the object is 10. Gravitational acceleration on the planet is 30 over 4. I think they have given, now 30 over 4 means how much? 30 over 4 means how much? 15 over 2. I think in the answers they have given only this value. They forgot to mention 10 into 15 over 2. So therefore, I think there's a mistake in that MCQ. I don't know. But if they ask weight of the object on the planet, this is how we get the answer. Right? So don't think about the MCQs. My way is correct. Raise your hands. How many of you understand what I explained regarding 2020 level? Raise your hands. Raise your hands. If you understand, raise your hands. Because I don't going to follow all the steps, right? Because when we're doing MCQs, I explain somewhat thoroughly, but not following all the steps, right? So coming days, especially now when we are going with our paper classes, what we do now. So I will, when we go more closer to the exams, then number of steps that I do, I will reduce. Right now, next month we are starting paper class. Now the time is not exactly decided. Right now, most probably it will be in weekends. So I won't do in weekdays. So mostly the paper class will be on weekends, right? Now in the paper classes, what we do, this paper class is not a typical paper class. How these paper classes are conducted in this Shakti Institute, I'm not going to do the paper class in that way. So normally they are calling most of the teachers in the institute. They do in revision paper class. What they do, they are discussing past paper questions in that they are revision paper classes. But you know that I discuss my past paper questions through this online sessions. So therefore, I won't discuss any past paper questions in that paper class. So therefore, what I do, so I will discuss now. We read a paper, right? It's a standard paper. It can be 35 MCQ paper, if not 50 MCQ paper. So it can be 4 structured essays, 4 essay question paper. If not, 2 structured essays, 2 essay question paper, right? So what we do in the paper classes, if we in the first week, if we not yet decided how to conduct these paper classes, roughly I'm telling, suppose let's say that in the first week, if we are writing the paper, if we write the paper on first week, if we have enough time after you guys wrote the paper, then I will start discussing that paper. Next week entirely what? We are discussing the paper. Then third week, again we are giving a paper. Fourth week, we are discussing the paper. So currently that's how I planned. If not, I have another plan now. Every day I thought of now, rather than going with full papers, I thought of give 25 MCQ, two structured essays, and two essays, right? Then not giving the complete paper, but reducing the content of the paper. Then every week I'm giving a paper. However, within that day, the same day, discussing the paper. So not yet discussed, but what I want to say is in the paper classes, actually, my paper class won't be a typical paper class. That means revision paper class. My paper class is not a revision paper class. So it's really a paper class. So that's what I want to say. So mostly we are doing the paper class on weekends. We are writing papers. In paper class, what we do, we write papers, model papers. So model papers means there are some good school papers, right? So what I do, and we have that Tondamana papers. Obviously, there are good school papers, and there are some model papers also. It is stand model papers. So what I do, I create papers based on good questions. So then we are practicing them. So that's what we do in the paper class. In addition to that, I will revise some important points as much as possible through the questions. So that's my current plan. So I will exactly let you know what we'll do in the paper class before next month. I will tell you. Right, okay. That part is done. Two MCQs discussed 2021, 2020. So I won't discuss question number 3. I will discuss later. Look at 2018. Acceleration due to gravity on the surface of a uniform spherical plant of radius RA and a uniform spherical plant capital B of radius RB are equal. If the mass of capital A is twice the mass of capital B. Now look at it. Now this question. Now 2018 A level. 2018. So it's your responsibility to redo these questions again after this session is completed. Within today, so you must redo these questions again. That's your responsibility. So therefore, make sure to redo these questions again as soon as this session completed. Right? Okay. 2018. Right? What they are telling? Question says that acceleration due to gravity on the surfaces of a uniform spherical plant A of radius RA, uniform spherical plant B of radius RB are equal. Now, when you consider two planets A and B, gravitational acceleration, if not field intensity, on the surface of plant capital A and on the surface of plant capital B, they are same. I say GG, but they have given radius of plant capital A is RA, radius of plant capital B is RB. Further, they mentioned that uniform spherical plants radius RA, RB. If the mass of capital A is twice the mass of capital B, let's say mass of capital B is capital M, then what must be the mass of capital A to capital M? Now they mention if the mass of capital A is twice the mass of capital B, then if your mass of capital B is capital M, mass of the capital A is 2 capital M, right? Okay. And what we want to find actually, we want to find the relationship between RA and RB. We need to find the relationship between RA and RB. So what we want to do, most of the MCQs, we want to apply what? G capital M equals GR squared. So what you want to apply? G capital M equals GR squared. G capital M equals GR squared, right? Apply this equation for planet A. Apply this equation for planet B. Problem solved, right? So now G is a constant. So therefore I can say what? Capital M is proportional to GR squared. If I apply this proportionality, capital M is proportional to GR squared. If I apply this proportionality for planet capital A, what is the mass of planet capital A? It's 2 capital M. Gravitational acceleration is simple G. Radius of planet capital A is RA. RA squared. So when you apply the same proportionality for the planet capital B, mass of the planet capital B is capital M, that is proportional to G RB squared. So let's divide it. When you divide these two, what will you obtain? If you divide these two, you will obtain what? 2 capital M over M means 2. If you divide these two, 2 capital M over capital M means 2. GG cancel out. RA squared over RB squared. Take the root. If you take root in both sides, we will obtain what? Root 2 equals RA over RB. RA means root 2 RB. Something like this. RA equals root 2 RB. I think first one is the answer, I think. Raise your hands who understood 2018 level. 2018 level understood. Raise your hands. Raise your hands. If you understand, raise your hands. Next one. 16. 60 says what? If the ratio mass of the planet over radius of the planet for planet A is 4 times that of planet B. Ratio of escape velocity at the surface of planet A over escape velocity at the surface of planet B is. Now look at it. Now they have mentioned mass of planet over radius of planet. For planet A is 4 times that of planet B. Look at it. 2016 11. In this case, mass of planet, radius of planet. I say mass of planet B is MB over radius of planet B is RB. Now they mentioned mass of planet A over radius of planet A. That is 4 times of the mass of planet B over radius of planet B. Am I correct? They mentioned if the ratio mass of the planet over radius of the planet for planet A is 4 times that of planet B, right? Then the ratio escape velocity at the surface of planet A, escape velocity at the surface of planet B. So what we want to find, VEA, VEB. So I say escape velocity as VA and VB. If I say my escape velocity as VAVB, I need to find this ratio. Now, can you remember? I explained. I'm not going to derive the equation for escape velocity if you are projecting an object from the surface of the planet. In right now, I'm not going to derive the equation for escape velocity. When you project the object on the surface of the planet, I'm not going to derive it. But you know that escape velocity equation is what? Escape velocity equation is, suppose if you are projecting the object from the surface of the planet, escape velocity will be what? 2g capital M over capital R whole root. Am I correct? Escape velocity equation will be 2g capital M over capital R root, right? How many of you say that this equation is correct? Raise your hands. How many of you say that this equation is correct? Raise your hands. How many of you say that this equation is correct? And if not, G capital M means what? G capital R squared. Then you can say what? 2gr root. I think I explained. Okay, this is the equation for escape velocity. Now I need to find escape velocity ratio. Escape velocity of planet A to escape velocity of planet B. The equation is this one. 2g is constant. Mass over MOR. MOR. Very easy. MOR. Problem solved. Look at it. This ratio equals what? This ratio equals VA over VB. What is your VA? Your VA is what? 2G capital M over R, G capital MA over R over escape velocity of planet B root 2G capital MB over RB. See? Then you want to understand this 2G cancel out. 2G cancel out. If I take for your understanding, If not names, no need to take root, no need to take square in both sides. Then you can say that ME over RA means what actually? ME over RA means I can write ME over RA in terms of MB over RB. Then I can write down VA over VB means what? Equals, instead of ME over RA, I can write down 4MB over RB. Am I correct? 4MB over RB whole root over MB over RB root. Then you want to understand MB, I can separately give this root for both of them. This root can be separately given for root 4 root MB over RB. Then MB over RB, MB over RB cancel out. You are getting root 4. What is the value of root 4? It's 2. Then ratio of escape velocity of planet A to planet B. Answer is 2. Understood? Raise your hands. Understood? Hands up. If you understand, raise your hands. Raise your hands. Someone if you understand. Right, okay. Then we discussed 16 also. So I will discuss. Don't worry, whatever the questions I skip, I will discuss. Don't worry. 2014. But what I want from you is someone please keep a record. The questions that I discuss, questions that I don't discuss, keep a record. 2014. Particle of mass simple m is projected vertically upwards from a point which is at a distance of 2 capital R. A particle of mass simple m is projected vertically upwards from a point which is at a distance 2 capital R from the center of a spherical planet having a mass capital M and radius capital R shown in the figure. Escape velocity for this projectile is, right? Okay, easy, right? Easy. So you can apply what? Conservation of mechanical energy. That's it. I taught you these things. 2014. Now you want to understand how this unit is easy. If you could now, as I mentioned, if you obeyed for what I told me, if you came for the 2 days and if you properly followed what I asked you to follow, then you can obviously take what 8.5 marks in your exams out of 100. Right now they have given what? Now you want to know that now the equation is you can directly say. The equation is you can directly say now. I don't know if you can remember or not. Now I told you that. Look at it. I told you that. Suppose if you are projecting now, if you want to find escape velocity of an object projected from the surface of the planet, what is the equation? Root 2g capital M over R. Am I correct? Suppose if you want to find the escape velocity of an object projected from the surface of the planet, the equation is root 2g capital M over R. And also I mentioned that suppose if you are projecting an object from simple h distance from the surface of the planet. Suppose if you are projecting the object simple h distance from the surface of the planet, what is the equation we learned, we derived to find the escape velocity? 2g capital M R plus h. Am I correct? 2g capital M R plus h. Then if you can remember that equation, those equations are not standard equations, but sometimes remembering standard equations, you can easily simplify. You can easily do the question, do the MCQs. So therefore, standard equations are not compulsory to learn by heart, but knowing them makes, if not increase your MCQ speed. You understand? Suppose if you forget this equation, what you want to do? You want to derive. So in that your exam time, you want to spend some time and you won't derive it. But you can derive it actually. But you can take the equation also. But what you sacrifice some sort of time. So therefore, knowing not standard equations also can increase the speed of when you are doing MCQs, right? Okay. Now if I derive this one, look at it. I say radius is capital R, height is simple h, we are projecting. Escape velocity is, let's say, I say escape velocity as v, escape velocity is v. So what we do usually, we apply what? Conservation of mechanical energy, right? So we know that suppose when we project this object with escape velocity, when this object reaches infinity, we know that kinetic energy is zero, potential energy zero. We learn these things. If you apply conservation of mechanical energy, we will obtain what? Kinetic energy of the object at this position is half mv squared, half mv squared minus g capital M simple M over capital R. This must be equal to kinetic energy plus potential energy at the infinity, both are zero. And then we will obtain what? Here it's not capital R, here it must be R plus H, my bad. Am I correct? Because total gravitational potential energy on the object minus G capital M simple M over R plus H. R plus H. You must remember the equation that derived is what? 2G capital M over R plus H. If you can remember this equation, you don't need to derive these things. In case if you forget this equation, because I told you this equation is not a standard equation. In case if you forget, if you don't this equation, then you can derive it. So what you sacrifice, only some small time, that's it. Simple and simple cancel out. Then we will obtain what? We will obtain the same equation, 2G capital M over R plus H root. Then you want to find the escape velocity. Instead of simple h, what is your simple h? Simple h is capital R. Then R plus h means what? R plus R. That means 2R. 2R, 2 to cancel out. Then what's your answer? Escape velocity will be G capital M over R. How many of you understand what I explained? Raise your hands. Understood. Raise your hands. How many of you understood? Right. Okay. Okay. Then 14 done. 13. The minimum velocity capital V that a particle should have in order to escape from a planet of mass capital M and radius capital R. Minimum velocity capital V that a particle should have in order to escape from a planet. I think if you can remember, it won't take less than 2 seconds. 2G capital M over R. I think you can say the answer, right? I don't need to explain. Answer is what? Root 2G capital M over R. 2012. So let's check 2012 A levels. What it says that? It says that if the distance between two masses is doubled, the gravitational force between them will be decreased by a factor of the Newton's law of gravitation. What is the Newton's law of gravitation? Gravitational force between two masses directly proportional to multiplication of the masses, inversely proportional to the square of distance. That's it. Then what is the equation derived from Newton's law of gravitation? F equals G capital M simple M over R square. So if you can remember that equation, the standard equation, you can easily find this answer. Right. So in this tube, I included all the MCQs, right? I didn't skip any MCQ. All the MCQs are included in this tube. 2012. Yes. So follow what I say, you can go for results. Distance between two masses double. Let's say there are two masses. Two masses. I don't know. They haven't mentioned these two masses are same or not. They haven't mentioned. So it doesn't mind. It does not need it. All right. I say this mass is I say capital M1, capital M2, whatever. So no matter these masses are same or these masses are different, that does not make any change in the question. Let's say the gap between these two masses initially is I say simple R. Different simply. Now they mentioned 2012 A level. They mentioned that if the distance between two masses is doubled, the gravitational force between them will be decreased by the factor of. Right. Now let's say gravitational force between these two masses. They are attraction forces. Let's say capital F, capital F, capital F, capital F. Now the distance is doubled. So you don't even want to draw this diagram, right? You don't even want to draw these diagrams. Okay, not need to draw diagrams. Okay. So then we can say equation is what? Gravitational force equals gravitational force between two masses. F equals G capital M simple M over R squared. So no matter both cases, what is same? M1, M2 multiplication is same. G is a constant. Then you can directly say gravitational force is inversely proportional to 1 over R squared. That's it. That's it. So let's say when the gap between these two masses is simply the force acting on the masses capital F, capital F is proportional to 1 over simple A square, proportional to 1. So when the gap is too simply, let's say gravitational force acting on the masses are F dash O, F1, F1. Then I can say that F1 is inversely proportional to 1 over R squared. This time what's my R? This time my R is 2 simple A. 2 simple A squared. 4 simple A squared proportionally 2. Right? Then if you divide by 2 by 1, if not 1 by 2, whatever. If I divide by 2 by 1, I will get what? F1 over F equals what? F1 over F equals what? 1 over 4. What is the factor? When F1 equals F over 4. What is the factor? Decreased by the factor of 4. You understand? It's decreasing by the factor of 4. How many of you understand what I'm saying? Raise your hand. Understood. Understood. Right, 9:15. 2012. Right, okay. We'll discuss 2011 as well. 11. A planet of uniform density has mass this much. Planet of uniform density has mass this much, radius, okay, gravitational potential at the surface of the planet. Then you must know the equation. So can you remember last Monday also, most of you could not remember the equation for gravitational potential. So if you can remember the equation, these are basic questions. So what is the equation for gravitational potential? V equals minus G capital M over R. V equals minus G capital M over R, basic substitution. Right? Basic substitution. The planet of uniform density has a mass this much, radius this much, a gravitational potential at the surface of the planet. Direct substitution. 2011 A level. 2011 A level. Equation is V equals minus G capital M over R. Is the equation. Now they have given V value as well. But don't forget to mention minus. Suppose if you underline a positive answer, it's wrong. Because always I mention gravitational potential at a point is always a minus value. G value is how much? 6.7 minus 11. 6.7 minus 11. Mass is how much? Mass of the planet is how much? 2 to the power 27. 2 to the power 27. Radius capital R. Capital R is how much? Capital R is about 6.7 to the power 7 meters. 6.7 to the power 7 meters. Then here minus 11 means minus 11 plus 27 minus 7. 20. 20. 20 minus 11 means how much? 9. 2 into 9. Minus. What must be the unit of gravitational potential? Joules per kilogram. Understood? How many of you understand this question as well? Raise your hands. Understood. Understood. Right, okay. 2009 A level. 2009. So one, please keep a count how many questions I discussed up to now from this past paper MCQs. Keep a count. 2009. How many of you need a break right now? Raise your hands. Need a break right now. Need a break right now? Raise your hands. How many of you need a break right now? No one. Okay. 2009. Radius of a spherical asteroid is 60 kilometers. Acceleration due to gravity on its surface is 3 ms minus 2. Escape velocity at the surface of the asteroid 2g capital M over r. Right? 2g capital M over r. Look at it. Now they're asking escape velocity on the surface of the asteroid. That means what? What is the equation? 2g capital M over r. I explain. Right? V equals what? Escape velocity equals 2g capital M over capital R whole root. Now, but now they haven't given mass of anything. Mass of the asteroid, I think they haven't given, I think, right? They haven't mentioned mass of the asteroid. But I told you that suppose if they haven't given mass of an object, what we do? We change G capital M as what? GR squared. Always convert your G capital M as what? GR squared. GR squared 2 over capital R whole root equals what? To your VE. Then 1R cancel out. What is the equation for your escape velocity right now? 2g capital R. Now you can find the answer. Now root. What is the value of g they have given? It's 3, right? 3 is minus 2. It's not minus 1. 3. Then R. Radius of the sphere they have given 60 kilometers, but make sure to substitute in meters. 60 10 to the power 3. Am I correct? Then here 6 to Cathy. 2 into 3 means 6. 8, 6. 10 to the power 4. When you take the root, what is the answer? 6 10 to the power 2. 600 ms minus 1. 600 ms minus 1. That's the answer. 2009 also discussed. 2007. 2007. Right. Okay. Question 2007 says what? Don't worry. Somewhat complex question. It's now questions I skip. They are also not complex actually. Right. After completing all these questions as much as possible, we'll try to go for that questions. Those are not complex questions. Okay. 2007 says what? An object of weight 100 Newton. So always understand now. After I finish today's session, it's your responsibility to redo these questions again and send as a PDF. Right? Even though I say or I don't say, we know that now since we started the classes, every day when I do a Zoom class, I ask you to send the homeworks after that session is finished. So therefore, no matter I ask from you, I don't ask, it's your responsibility to redo these questions again and send me. But some students, what they do, they send the PDF. That PDF is now they do the question. Now they send the PDF, but that PDF is not. PDF is related to now. Now when I explain something, they write down. Now when I explain the entire the session, when I explain the questions, now some students write down my what, my steps and my everything. What some students do some students do what? Some students they send that PDF right now. But what I want from you is after the session is completed, what I want from you is so you want to read these questions again. So now because they keep away your tiredness, keep away your what laziness. So if you redo these questions again, you will have some sort of confidence. And then you realize exam questions are not difficult. So when you realize that exams questions are not difficult, if I properly plan and if I study, you will feel that I can go for a result. So therefore, you don't lie me because sending the PDF to me, I don't expect from you actually. But it's your responsibility to send the PDF. But after session completed, you want to redo these questions again by your cell phone. Then that read it questions you want to send me. That's what I'm expecting from you. Anyways, but some people don't give so much priority for those things. They think they know it, but one day will suffer. 2007 A level, an object weighs 100 Newton on the Earth's surface when it is carried to a height equal to the radius of the Earth. From the Earth's surface, its weight becomes. Now look at it. Now here they considered. Everyone leave a reply. I'm expecting reply from all of you. Now 2007 LL question says that an object weighs 100 Newton on the Earth's surface. Leave a reply. What is the gravitational acceleration? If not, what is the gravitational field intensity on the surface of the Earth? According to this given data, what is the gravitational acceleration on the surface of the Earth? Everyone leave a reply quickly. Leave a reply. What must be the gravitational acceleration on the surface of the Earth? They considered G as what? 10 ms minus 2. But normally when we do questions, we usually apply 9.8 ms minus 2. But for the easiness to simplify the simplifications. If you take 9.8, it makes simplification complex. So therefore, what have they done? They are considering, most of the MCQs, they are considering gravitational acceleration on the surface of the Earth is about 10 ms minus 2. Then you can easily find the mass of the Earth. How much? Sorry, mass of the object. Now they have given what? Weight of the object. They have given an object weighs 100 Newton. So if you realized gravitational acceleration on the surface of the Earth is about 10 ms minus 2, you can easily come to a conclusion. Mass of that object is about 10 kilograms. Okay. Then if you can find the gravitational acceleration at a point, capital R distance from the Earth, if you can find the gravitational acceleration at a point, capital R distance from the surface of the Earth, problem solved. Okay. Now look at it. Now, what is the equation for gravitational acceleration? If not gravitational intensity, equation is what? We know that G capital M over R squared, right? G capital M over R squared. Now, right? Now we know gravitational acceleration. If not gravitational field intensity on the surface of the Earth is how much? Simple G, that is 10 ms minus 2. If not 10 newtons per kilogram. Now, if you can find the gravitational acceleration, if not gravitational field intensity at a point which is capital R distance from the surface of the Earth, problem solved. Right? Then we know that gravitational acceleration equals G capital M over R squared. G is a constant, capital M, mass of the planet is a constant. We can say gravitational acceleration is proportional to 1 over distance squared. 1 over distance squared. Then, if you apply a point on the surface of the Earth, if you apply this proportionality on a point which is on the surface of the Earth, 10 proportional to what? 1 over capital R squared. Proportionality 1. But you need to find gravitational acceleration at a point which is capital R distance from the planet, from the Earth. I say that gravitational acceleration is simple G dash or G1. G1 is proportional to 1 over. What is the distance to this point from the center of the Earth to capital R? 2 capital R whole squared means how much? 2 capital R whole squared means how much? 4 capital R squared proportional to 2. If you divide 2 by 1, G1 over 10, 1 over 4. You'll obtain what's your G1? New gravitational acceleration. If not, gravitational acceleration at this point is about 10 over 4. If you want to find the weight, multiply by the mass. 100 over 4, 25 newtons. Understood. Raise your hands. How many of you understand? Understood. Understood. We'll take a break. Now time is 9:26. How many of you want to take 10-minute break? Raise your hands. 5-minute break or 10-minute break? How many of you want 10-minute break? Raise your hands. 10 minutes. 10 minutes. Raise your hands. How many of you need 5-minute break? Raise your hands. How many of you need 5-minute break? 5 minutes. 5-minute break. Right. Okay. Take 10-minute break and come. Now time is exactly 9:27. Come at 9:37. 9:37. 9:37. Ten, 10 piece, 12 piece. 10 or 12. 10 or 12. Okay, right. Right. Okay, right. Okay, we'll discuss. We'll discuss. Right. Now we discuss 2009, 7 discussed, and 2006 A level. 2000. Okay, now look at here now this 2006 A level question number 17. Question number 17. Look at it. Now, as shown in the figure, 2006 A level. In that 2006 A level, question number 17. As shown in the figure, two satellites, capital A and capital B of mass A and MB, move around a planet capital P in a circular orbit with speed VA and VB respectively. The radii of the orbits are simple r and 2 simple r respectively. The ratio of VA to VB is. Now they have given a planet. That planet is capital P. There are two satellites, capital A and capital B, orbiting around that planet. Let's say if this is my planet, two satellites. So this planet is planet capital A. It's moving around a planet. It's moving around an orbit. Let's say orbital radius. They have mentioned how much. Orbital radius is about r. Orbital radius of capital A planet is r. Orbital radius of capital B planet is how much? That is 2 simple r. Orbital radius of capital B planet is how much? 2 simple r. 2r. Right? Okay. Planet point A, point capital B. Now what we want to find? Now we want to find the velocity ratio VA to VB. Right? Now that means, let's say tangential velocity of the satellite capital A is, I say, VA. When this satellite is moving in a circular motion, tangential velocity of the satellite at point A is, I say, VA. Tangential velocity of the satellite capital B, I say it's VB. It's VB. Then now what's our goal actually? Now I want to find VA to VB ratio. That's my goal actually. I want to find VA to VB ratio. So VA to VB ratio. So somehow you want to find this ratio in terms of what? Radius ratios. Okay, you want to find this VA to VB ratio by using this simple R data. Now just consider when a mass moves around an orbit. Okay, when a mass moves around a mass in an orbit, what we do? So normally when a mass is moving around a mass in an orbit, what we do usually? We apply F equals ma. We usually apply F equals ma. We usually apply F equals ma. Then what is this force? Centripetal force. Now most of the times when we are talking about gravitational field questions, this centripetal force is provided by gravitational force. Now what is the equation that we learn to find the gravitational force? From Newton's law of gravitation, G capital M simple M over R squared. G capital M simple M over R squared. That is equals to, I say simple R squared. I say simple R squared or capital R squared. No issue. Then simple M. Now here simple M is centripetal acceleration. Now I need to find this velocity ratio. So therefore now we know we can write centripetal acceleration in two different ways. Centripetal acceleration means what? It's V squared over R. If not, we can write down centripetal acceleration as what? Centripetal acceleration as R omega squared. R omega squared. Now I thought of going with this option because I want to find velocity ratio. So therefore V squared over R. So 1R cancel out. One simple M cancel out. That means you will obtain tangential velocity of an object moving around a mass in an orbit can be obtained by what equation? V squared equals G capital M over R squared. Now what is this capital M? Not mass of the satellite. What is this capital M? Mass of the planet through which this satellite is orbiting. So capital M means what? Mass of the planet. And then I can say, when you consider, now this is the equation. So you are going to apply this equation for planet A, you are going to apply this equation for satellite A, satellite B. So both the satellites are rotating around, both satellites are moving around planet capital P. So therefore this capital M is same for both the cases. So therefore I can say tangential velocity squared is inversely proportional to distance squared. So if we apply this proportionality for point capital A, tangential velocity at point capital A, VA squared inversely proportional to 1 over R squared. If you apply this proportionality for satellite capital B, VB squared is inversely proportional to what? 1 over distance to the satellite capital B from the planet is 2 simple R. 4 simple r squared. If you want to find VA to VB ratio, VA squared over VB squared equals what? 1 over r squared over 1 over 4r squared. That means 4. The answer is what? VA to VB equals what? VA to VB equals 2. How many of you understand VA to VB equals 2? Raise your hands. How many of you understand VA to VB equals 2? Raise your hands. It's R. It's R and 2R. It's R and 2R. Okay. Raise your hands. How many of you understand what I explained right now? Raise your hands. Right. Okay. So then 17. Then we'll discuss about 2003 A level. 2003 A level says what? The mass of Mars is 0.1 times that of Earth. The mass of Mars 0.1 times that of Earth. If I say mass of the Earth is capital M, mass Earth. If I say mass of the Earth is capital M, what is the mass of the mass? 0.1 times mass of the Earth. That means 0.1 capital M. If your mass of the Earth is capital M, what is the mass of the mass? 0.1 times capital M. That is okay. Understand? Distance between the sun and the Mars is, because we know that Mars is moving in a circular motion around the sun. Earth is moving in a circular motion around the sun. Now they have mentioned distance between the sun and the Mars. Distance between the sun and the Mars is 1.5 times the distance between the sun and the Earth. Distance between the sun and the Mars is 1.5 times the distance between the sun and the Earth. If I say distance between the sun and the Earth is, I say simply, what is the distance between the sun and the Mars? 1.5 times. Right? 1.5 times. Simply. 1.5 simply. If this is your sun, if you say distance between sun and the Earth is simply, what is the distance between the sun and the Mars? 2 simply. That's what I mentioned here. You don't even want to draw a diagram. This way, if you represent your data, that's enough actually. If you feel it's if you want to represent a diagram like this, is completely all right. So when you're doing MCQs, so you must try maximum to complete the MCQ within maximum minimum time. Try to finish the MCQs very quickly, as much as possible. That's very important. Okay, what we want to find? Gravitational force of attraction between Sun and Mars. Gravitational force of attraction between Sun and Earth actually. I say gravitational force between Sun and Mars is, I say, capital F1. Gravitational force between Sun and Earth is, I say, capital F2. And then I want to find F1 to F2 ratio. F1 to F2 ratio. I need to find F1 to F2 ratio. Now we know that. Let's consider general situation. Suppose if a planet is revolving around the sun, what we do? We apply F equals ma. We apply F equals ma. F equals ma. Now F means gravitational force. Gravitational force. G capital M simple M. This time now this time you don't want to apply F equals ma. Just think about sun and mass. If you think about sun and mass, let's say mass of the sun is simple M. Let's say mass of the sun is simple M. Mass of the Mars is 0.1 capital M. If you want to find the gravitational force between sun and Mars, what we do? What is the equation? F1 equals G capital M. So that means mass of the sun, mass of the Mars over distance between sun and the Mars, 2 simply whole square. That means 4 simply squared. So if you want to find the gravitational force between Sun and Earth. F2, that is equals to what? G capital M simple M R squared. Now here, mass of the Sun, mass of the Earth. Distance between Sun and Earth is simple A squared. If you divide 1 by 2. 1, 2. If you divide 1 by 2, what is the answer? F1 to F2 ratio equals to what? F1 to F2 ratio equals to what? G simple M, what? Capital M cancel out. A squared cancel out. Answer is 1 of 1 of. But wait, I made a mistake. Here I must now I made a small mistake, okay? Because now distance between Sun and Mars is not 2 simple A, 1.5 simple A. My bad, 1.5 simple A. Then if when you apply this equation F1 G mass of the Sun into mass of the Mars, distance between Sun and Mars is 1.5 simple A squared. 1.5 squared simple A squared. When you divide F1 by F2, look at here, 0.1 is there, 1.5 squared is there. Then you will obtain F1 over F2 as 0.1 over 1.5 squared. Raise your hands. How many of you understand? Understood? Raise your hands. Understood. Raise your hands. If you understand, raise your hands. Now, someone leave a reply. How many questions we discussed so far? How many questions we discussed so far? How many questions? How many questions we discussed so far? 12. Right, okay. 2001. The mass and the radius of the Earth is capital M and capital R. Mass and radius of the Earth is capital M and capital R. Okay. Escape velocity of the rocket of mass simple M on the Earth's surface. 2g capital M. Okay. 2g capital M O capital R. That's the answer. 2g capital M O capital R. That's the answer. Direct answer. If you can remember that equation, it won't take 2 seconds. 2011. A geostationary satellite. Then I explained what is geostationary satellite, right? On that day, I explained what are the important characteristics that you want to know regarding geostationary satellite. I explained. A geostationary satellite, capital A, moves in an orbit of radius RA, right? Another geostationary satellite, capital B, has twice the mass of capital A. Twice the mass of capital A. The orbital radius of the satellite capital B is. The orbital radius of the satellite capital B is. Now everyone leave a reply. Everyone leave a reply. Suppose if the satellite is geostationary. Very carefully listen. Suppose if the satellite is geostationary, what is the time period of the satellite? Leave a reply. What is the time period of the satellite? Everyone leave a reply. Leave a reply. Suppose if the satellite is geostationary, what is the time period of the satellite? Leave a reply. 24 hours. Now they are talking about two geostationary satellites. Geostationary satellite capital A, geostationary satellite capital B. What can you say about the time period of satellite capital A and satellite capital B? Same, 24 hours. So time periods of these two satellites are same, capital D, capital T. Right? Okay. Then they are asking, okay, 2011. 2011. 2011. Right. Now, geostationary satellite capital A, geostationary satellite capital B. Both of them have same time period TT. Okay. Now, what else? Satellite A moves in a orbital radius RA, orbital radius of B satellite is, let's say, RB. Actually, I want to find RB in terms of RA, but they have given masses. Satellite B has twice the mass of A. Let's say mass of satellite B is satellite B has twice the mass of A. Mass of the satellite A is simple limb. Mass of the satellite B is 2 simple limb. Right? Okay. Then, okay. Now what do you do? So geostationary satellite means if this is our Earth, we'll consider one general geostationary satellite. When you consider one general geostationary satellite, this is my geostationary satellite. Let's say distance to the geostationary satellite from the Earth is, I say simple r, from the Earth is simple r. Simple r. That means orbital radius of the satellite is simple r. So what we do usually, now this stationary geostationary satellite is moving in a circular motion. What we do, we apply F equals ma, right? We apply F equals ma. We apply F equals ma. So when we apply F equals ma, F means gravitational force, G capital M, simple M over R squared. Here simple M, mass of the geostationary satellite is simple M. Centripetal acceleration means what? R omega squared. Why I decided R omega squared? Because now we know that both the satellites time period is same. So therefore I thought of right now R omega squared, understand omega squared. What is my omega? 2 pi over capital T. Right now you know why. What is my omega? 2 pi over capital T. R omega squared. Omega means what? 2 pi over capital T means what? 4 pi squared capital T squared. Simple M cancel out. Then I can say what? I can say what? I can say, look at it, I can say, if I subject R, if I bring this R square this side, if I subject R cube, my R cube will be T squared G capital M over T squared G capital M over 4 5 squared. Right? How many of you understand up to here? Raise your hands. How many of you understand up to here? Raise your hands. Understood up to here? Raise your hands. Raise your hands quickly. So keep your focus. Because now I won't discuss now. Whatever the past paper questions I discussed up to now, I don't discuss again. Right? But I told that I will discuss all the past papers for last 20, 30 years. I will do that. But whatever the past paper I discussed before, I won't discuss it. Even in mechanics, essay questions, I have discussed more than 15 years past paper essay questions in mechanics. So I'm not going to discuss them again. Right? It's your responsibility to join these sessions and gather the knowledge and go for results. It's your responsibility. Anyways, okay. Now, okay. Now look at it. I'll ask a question. Everyone leave a reply. Look at it. Look at it. I'll ask a question. Everyone leave a reply by using this equation. Now we want to find RB in terms of RA. Look at it. What I want to find is, I want to find the orbital radius of capital B geostationary satellite in terms of orbital radius of capital A geostationary satellite. That's my goal actually. How many of you think that? How many of you think that? Raise your hands. How many of you say that? Radius, orbital radius of the geostationary satellite depends on their mass. Raise your hand. How many of you say that? Orbital radius of a geostationary satellite depends on their mass. Raise your hands. Raise your hands. How many of you say that? Radius of geostationary satellite depends on the mass of the satellite. Raise your hands. How many of you say that? Radius of geostationary satellite depends on the mass of the satellite. Raise your hands. How many? How many of you say that? No. Radius of the geostationary satellite does not depend on the mass of the satellite. Raise your hands. Raise your hands. Here capital M means not mass of the satellite. Here capital M means what? Mass of the planet, right? So therefore understand does not depend on mass. Now G is a constant, capital M means mass of the planet. Don't misunderstand. Here capital M means what? Mass of the planet. That means Earth. Mass of the Earth. Time period for both the planets, both the satellites, A and B same. Then 4, 5 square is a constant. Then what can you say about the orbital radius of geostationary satellite capital B and satellite capital A? What can you say about the orbital radius of geostationary satellite capital B and capital A? Leave a reply. They must be equal. They must be equal. How many of you understand radius of geostationary satellites are equal? Raise your hands. Raise your hands. Right, okay. The next one. Okay. 1999. Radius of the okay. Okay, you guys do the question and okay, will you guys do the question? Mm. Everyone start doing 1999 A-level. Question number 22. Everyone start doing 1999 A-level. Question number 22. Quickly. Start doing. Start doing. Start doing. Start doing. Right, okay. Finished? If you got the answers, put the answers in the chat box. If you got the answers, put the answers in the chat box. If you got the answers, put the answers in the chat box. Quickly. 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 1999. Yes. Quickly. 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 How many of you still doing the question? Raise your hands. Still doing the question? Raise your hands.
Still doing the question, raise your hands. Quickly, quickly. Do it quickly. 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 Don't waste the time. Quickly. Right now. So today we'll see now. So usually I want to keep a session maximum less than 2 hours. That's my goal. Now we started today at 8:30. 8:30, 9:30, it's 10, 10, 5. We'll see. We'll see. Because now if we can finish MCQ section gravitational field today, then we can discuss essay questions one another day, and we can completely finish all the past paper MCQs, essays, and cute questions. Then my job is completed, right? The going through the questions again and preparing a short note and revising them again and again. So your responsibility. It's your responsibility. Still trying? Raise your hand. Still trying. Still trying the question? Raise your hands. How many of you got the answers? Raise your hand. Somewhat, whatever the answer. How many of you got the answers? Raise your hand. Right. Okay. Okay. Right. Okay. I'll discuss. The radius of the Earth is capital R. Simple G is the acceleration due to gravity at the Earth's surface. Now let's say this is our Earth, right? This is our Earth. Now they have mentioned radius of the Earth is capital R. Radius of the Earth is capital R. Okay, right. Simple G is the acceleration due to gravity at the Earth's surface. Gravitational acceleration, if not gravitational field intensity on the surface of the Earth is simple G. Okay. The gain in potential energy of an object of mass simple m raised from the surface of the Earth to a height capital R is. Now let's say now there is a mass. It's simple m. Mass of this object is simple m. When you are moving that simple m mass from the surface of the Earth to a height capital R, to a height capital R, what must be the change in gravitational energy? Do you understand? When you are bringing your mass simple m from the surface of the Earth to a point which is capital R distance from the Earth, what is the change in gravitational potential energy? That's what they ask. Then you can easily find, I say this point is point capital 1, this point is point capital 2. We know that. What is the equation? What is the equation to find the gravitational potential energy? The equation to find the gravitational potential energy is what? Minus G capital M simple M minus G capital M simple M over R is the equation, right? Is the equation. Then shall we find the gravitational potential energy at point 2? Minus G, let's say mass of the Earth is capital M. Let's say mass of the Earth is capital M, simple M, over the distance to point capital 2 from the surface of the distance to point capital 2 from the center of the Earth. R plus R, 2 capital R. This is R. The radius is also R. 2 capital R. What is the gravitational potential energy of simple M mass when the mass is on the surface of the Earth? Minus G capital M simple M, the distance between the mass and the center of the Earth, capital R. Then if you want to find the change in potential energy, final potential energy minus initial potential energy. minus G capital M simple M over 2 capital R minus minus G capital M simple M over R, right? So then it will become what? Minus become plus me. So plus G capital M simple M over R, G capital M simple M over R minus G capital M simple M over 2R. Now you guys know what? Now we can take what? G capital M simple M over R as our common factor. So if I take G capital M simple M over R as my common factor, I will get 1 minus half. 1 minus half. What is G capital M? We know that G capital M means what? GR squared. G capital M means G R squared. So therefore we can substitute, instead of G capital M, I can substitute what? G R squared simple M. 1 minus half means half, 2 capital R. 1 R cancel out. MGR over 2. Raise your hands. How many of you understand it's MGR over 2? Raise your hands. How many of you understand it's MGR over 2? Raise your hands. It's done. So then quickly go to 1998 A level. 1998 A level. 1998 A level. In this case, 15. 1998 A level. Genuinely, how many of you got the answers for 1999? Raise your hands. How many of you got the answers for 1999? Raise your hands. How many of you? Raise your hands. Genuinely, you got the answers. How many of you? There are 1, 2, 3, 4, 5. There are 6. How many questions we discussed so far? Leave a reply. How many questions we discussed so far? Quickly. Leave a reply. Leave a reply. 16. 16. So we'll we'll continue. 1998. Assume that moon is a sphere of radius capital R with G dash as the acceleration due to gravity. Assume that moon is a sphere of radius capital R with G dash as the acceleration due to gravity at the surface. If the universal constant of gravitation is capital G, mean density of the moon is given by. It's very easy. Very easy. Now they have given gravitational acceleration on the surface of the moon as G dash. They have given gravitational acceleration on the surface of the moon as G dash, right? So when you do this MCQ, please don't draw the diagrams. For your understanding, sometimes I draw the diagram. When you do this MCQs, don't draw the diagram. G dash, radius given as capital R, radius capital R. What else? Now they have given universal constant G. What we want to find? We want to find density. Now, if you want to find density, what is the equation you want to apply? G capital M equals GR squared. Equation is what? G capital M equals GR squared. Now we know G. Now mass means what? Volume into density. Mass means volume into density. Volume of a sphere 4/3 phi r cube. Density of the sphere is rho. Mass means what? Volume into density. If it is sphere, what is the equation for volume? 4/3 phi r cube into density equals to G dash R squared. R squared here R cancel out. If you want to find an expression for density, subject density. Density equals what? 3G dash 3G dash 45 R capital G. Density equals what? 3G dash 45 R capital G. How many of you understand? Raise your hands. Understood. Raise your hand. Understood. Raise your hands. If you understand, raise your hands. And 17 done. Right, okay. Then 1997. The weight of an object on the Earth's surface is 600 Newton. Weight of the object on the surface of the Earth is 600 Newton. At a height of 1 Earth radius above the Earth, weight of the object will be. This question is also very similar to a question that we discussed today. Now they have mentioned there's an object. That object's weight is 600 Newton. Then please tell me, we know gravitational acceleration on the surface of the Earth is 10 ms minus 2. Then what is the mass of that object? 60 kilograms, right? If the gravitational acceleration on the surface of the Earth is 10, what is the mass of that object? 60 kilograms. If you can find the gravitational acceleration at a point, capital R distance far from the surface of the Earth, problem solved. Very easy, right? 1998, sorry, 1997. 1997. Now 1997, look at it. Look at it. 1997. Now this case, what is the equation for gravitational acceleration if not gravitational field intensity? G capital M over what? R squared. Gravitational acceleration if not gravitational intensity equals what? G capital M over R squared. Okay. Right. Now we know gravitational acceleration on the surface of the Earth is simple G if not 10. Radius is R. Now we want to find the gravitational acceleration capital R distance from the surface of the Earth, this point. I say it is G1. This is the equation. Mass of the planet is capital M. It's constant, G constant, then you can say gravitational acceleration. If not gravitational intensity, inversely proportional to 1 over R squared. If you apply this proportionality at a point on the surface of the Earth, 10 is proportional to 1 over R squared, proportional to 1. So if you apply this proportionality for the point that you want to find the gravitational acceleration G1, proportional to distance 2r, 1 over 2r squared. That means 4r squared, proportional to 2. If you divide 2 by 1, you will get the answer. If you divide 2 by 1, you will get what? You will get that G1 over 10 equals what? G1 over 10 equals what? 1 over 4. 1 over 4, that means G1 means what? G1 means 10 over 4. Now we know if you want to find the weight means mg dash, mg1, mass is 60 kilograms, G1 is 10 over 4. 600 over 4 means I think 150 newtons. 600 over 4 means 150 newtons. Raise your hands, how many of you understand? Raise your hands, how many of you understand? Raise your hands, how many of you understand what I explained right now? Raise your hands. Okay. Then, okay. Now, right. 1996. Okay, we'll go with the what. How many of you want me to discuss the questions until 10:30, 10:45? No, usually we keep a session less than 2 hours. That's obvious. Obvious. Now, still, I also want to keep the session less than 2 hours based on your interest. Okay, based on your interest, we'll come to a conclusion. Right. So now I will give two options. One option is 10:30. One option is 10:45. So based on the majority interest, I will go with the majority's choice. Okay. Raise your hands. How many of you want me to do the session until 10:30? If you want, raise your hand. Don't wait until others reply. Okay. If you want, raise your hand. How many of you want me to do the session until 10:30? Raise your hand. 10:30 until 10:30. 1, 2, 3, 4, 5. How many of you want me to do the session? Okay, 1, 2, 3, 4, 5, 6. How many of you want me to do the session until 10:45? Raise your hands. 10:45. Raise your hands. 10:45. 10:45. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Okay, we'll stop at 10:30. Then 1996. If capital M and capital R are the mass and the radius of the planet. 1996. If capital M and capital R are the mass and the radius of the planet, mass respectively. G is universal constant of gravitation, acceleration due to gravity at the surface of the mass is. Very easy, right? What is the equation we learned for gravitational acceleration, if not gravitational intensity? G equals G capital M O R squared. G capital M O R squared. That's the answer. Basic. G capital M O R squared. 1995. 1995. Two planets X and Y have masses mx, my, rx, ry respectively. If the acceleration due to gravity on the surface of the two planets are easy. Same ratio. Look at it. Then we are stopping. If we discuss 1995 A level question, then we discuss 20 MCQ today. Within less than 2 hours, we discuss 20 MCQs. Remaining MCQs and past paper essay question will be discussed another day. Night before this week, I will do another session for you people. Yeah, maybe, right? Then they have mentioned two planets X and Y, X and Y, X and Y planets, and they are telling masses of the mx and my. What else? They mentioned about radius rx, ry, rx, ry. What else? Acceleration due to gravity on the surface, gg. Same gravitational acceleration on the surface is gg. Okay. They are asking ratio of mx ry square. They are asking mx ry squared over my rx squared. My rx squared. Okay. Now they are asking a value for this one. A value for this one. Now how do you find a value for this one? Even I have no idea actually. But now they have given this idea. So I can apply what? G capital M equals GR squared equation. Right? Then capital M. Capital M, look at it. Then I can easily get me. Look at it. Look at it. Look at it. If I bring R squared this side, capital M over R squared equals G over capital G. If I apply this equation for, now I can alter, look at it, I can alter this result in this way. Mx over Rx squared, right? My Ry squared. Same equation I can alter in this way. Mx Rx squared over my ry squared. How many of you agree that this equation is same as this one? Raise your hands. How many of you agree that this equation is same as this one? Raise your hands. How many of you agree? How many of you agree? This is same as this one. Think, look at it. Mx Rx squared division My Ry squared. Division means cross multiplication. Look at it. Mx Rx squared multiplication Ry squared My. Then same. Mx Ry squared My Rx squared. What is the answer? Okay, I will ask the answer. What is the answer? Everybody reply. What is the answer for this ratio? What is the answer for this ratio? Leave a reply. Then we are stopping. What is the answer for this ratio? Everyone leave a reply. The last question. What is the answer for the ratio? Leave a reply, everyone. What must be the answer for that ratio? Leave a reply. I received only one reply. Leave a reply. If you look at this one and that one, problem solved. I'm asking by looking at this result and this result, what is the answer for this ratio? From this ratio, leave a reply, everyone. What is the answer for that ratio? Leave a reply. Leave a reply. When someone is replying by looking at that, please don't say you also same answer. If you have different answer, please tell your answer. Be humble. Leave a reply. 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 Only 4 replies. What about others? Only 4 replies. Leave a reply, everyone. Look at here. Look at it. Now, if I apply this for x plus alpha parent y, then also I'm going to obtain my over ry squared as what? G over capital G. If you divide mxr squared over my ry squared, what is the answer? G over a, G over G, G over G. Answer is 1. Right, okay. Now, today we discussed 20 MCQs in Unit 5 Gravitational Field past papers. Right? That means I discussed last 20-year past paper MCQ questions in Unit 5. Now we have less than, I think all the questions are around all the past paper questions from 2021 to 2022 to 2000 1994. All about there are 27 questions. Now all the past paper questions for all the past paper questions from 2022 to 1994. There are about 27 MCQs. Today I discussed 20 MCQs. That means almost I discussed. There are one or two good questions as well next day. So I don't know, this week I will conduct additional session, I don't know. But somehow I will do the remaining 7 past paper MCQs and I will go to past paper essay questions in Unit 5. Genuinely raise your hands. Whatever I explained today, raise your hands. Whatever I explained today, you understand, raise your hand. Whatever I explained today, raise your hands, you understand. Whatever I explained today, raise your hand. Now what you want to do is as a homework. I don't need to remind this, okay? When you come to a session, it's your responsibility. Now today, now time is 10:30. I started at 8:35, then less than 2 hours. Now time is 10:30. What I want from you is take a small break, wash your body, drink something, whatever, and sit in your table, the chair, and redo these questions by yourself or send the PDF. I'm not going to ask from you, but if you do, it's beneficial for you. That's it. Okay, then session is finished. Have fun. Have fun.